Hi, can you hear me? It's okay. So today I'm going to speak about Scala tree and what it means to us. But before I start, I'd like to tell you a bit more about my team and what we use Scala for. My name is Joan. I'm a data engineer in the streaming, data science, and engineering team at Netflix. So this is what most of my friends tell me. Netflix is just streaming movies. I don't see what else you're doing there. So you're probably wondering what we do, right? So what these friends are telling me is that we're just a bunch of servers and you're watching Netflix right from our servers. The problem is that we take 15% of the internet traffic. So we're in front of YouTube, so this is because of me if 15% of the traffic internet is gone. And it goes all the way to 40% at peak time. So if we come back to our schema here, as you know, we are hosted on AWS, so we don't own any servers. And if you're watching Netflix, you're probably watching it from an ISP like NTT Docomo. And so if we apply this at our scale, it looks like this. And so both Netflix and the ISP would have to pay a lot in transit cost in between us. And probably the ISP wouldn't be happy because we would basically explode their network. So what we do instead, we are actually partnering with ISPs to put a device directly in their network, as close as possible to the users. And so everyone gets back their transit cost, and the latency is much lower for the users. So this is one way of doing. So this is the holy grail of Netflix. It's a bit like the CAP theorem in database, if you know the CAP theorem. And basically, what it tells us is that we cannot have all three at the same time. So, for example, if you want to start your video fast, you will have to cut on quality or have more rebuffers, and it works in all the ways, right, basically. And so at Netflix, we believe that we can push forward all three of them more and more, and that's what my team does. So to do so, every decision that we do, everything we deploy is data-driven, and we do a lot of A/B testing. So what is an A/B test? Let's say, for example, we want to try a new UI. We would take 1 million of users, and we would deploy this version for this 1 million of users, and we would compare it with another 1 million of users that is still on the previous version, and we would compare the conversion rate if people are happier with this new version and so on. And we do a lot of testing for this. We've been able to improve encoders compared to iTunes here. This is a 2-hour movie, by the way. And we also use this A/B testing for trailers and the images. I don't know what you think about this one. I would probably click on this one instead of this one. It looks much more badass. So there is another thing that we do. I don't know if you know about the Chaos Monkey. This is an open source project that we developed internally. And so what the top graph is saying is the number of stream start per second, the number of people starting a movie every second. I had to remove the numbers on the left because this is confidential, but this is like tens of thousands of people starting a movie every second. And the 3 graphs below are for each regions where we are deployed in. And so the Chaos Monkey just shut down one morning the whole EU region randomly. And so we can see that there's no impact on global stream starts per second, and that the 2 other regions in US took over the traffic. So it's pretty cool because if one continent goes down, you'll still be able to watch Netflix, probably. All right, so just wanted to do this little introduction to tell you like how data is important at Netflix. and we are using quite a lot of Scala to process this data. And obviously, we are excited with the new release of ScalaMatsuri. And so just to make it clear, Netflix is not involved in any way into the design of the language. But I took this opportunity to kind of reverse things a bit and you know, speak about the issues that we had with Scala 2 and how ScalaMatsuri might solve them. So there's 10 episodes, and there's no particular order in them. So the first one, limited enumerations. So what people will do, I guess, is this probably the official way of doing an enumeration. You extend enumeration. There's a little bit of type warring here. And then, you know, we have like start, pause, some values, right? And so I guess if we are doing this, it's because we get the benefits of having those functions like values and with names, with name. That's one way of doing. Other people are also creating sealed threads and case objects into a namespacing object like this. And the reason why people would do this is because you can extend it, right? You can, here I just added a parameter, but you can implement them and so on. It's much more flexible. But you lose the benefit of having values and with name with that. So what most of people do, maybe not most, but there's this library called Enumerations. And you know, it's a bit more involved, and it's based on macros, but it brings back a lot of utility functions like values and with value. So it sounds a bit clunky, right? In ScalaMatsuri, we have this enum keyboard. And yeah, so pretty simple. And if you want to extend it, you can do so this way. And you get the benefits of enum values and all the stuff that we had with extending enumeration. And so a bonus point, if you extend Java lang enum, you basically back compatible with Java. So from Java you can call this enum and it will all work fine. We have some Java at Netflix still, unfortunately, and every time we have to do an enum, we have to do it in Java because some Java guys will come to us and tell us, I can't call your enum. All right, so next one, Elther and Coproducts. I guess most of you guys are doing this, right? So let's say we have two functions, an audio function that gives you the audio for a given movie ID, and it can fail, right? So many people are using either, we are also, either not found exception or the array of bytes which represents the data of the audio. And subtitles, for example, this one can fail in multiple ways. It can have an illegal argument exception because if you give an offset, a movie offset that is less than 0, or you know, it can be not found, for example. So we see that in the type, we are already losing some information. We just know that it can return an exception. We don't know it can return an illegal argument exception or a not found exception. So in ScalaMatsuri, I was wondering, this union type, what can we use it for in real life? Because like having a union of like Boolean and string is not very real life. And here is like a good use case, real life use case, where you can actually say like, you know, if we look at subtitles, subtitle function, it can return a string or all the possible ways it fail. And so yeah, this is about more literal types, which actually came in 2.13 recently, and we already had this support with the refined types from Thomas. I don't remember his name, but yeah, you can reduce the number of possibilities in the parameters of your function by just doing int refined positive, right? Nulls. The $1 million mistake. I had to do one of this. Sorry. So pretty common, right? Someone assign null, and you're like, oh, okay, I'm going to call the duration of this movie, and boom, at runtime. So what's the solution? Do not use nulls. And so what people use instead, they use options, and they map over it, right? This is pretty good. But what if you're depending on a Java library, for example, or some library that you don't control returns null? So in ScalaMatsuri, this won't. Actually, this is not going to be directly Scala 3.0, but Scala 3.1, something like that. Basically, null, which is of type null with uppercase N, won't be a subtype of all the types, like nothing. So this won't compile, basically. And so what you will have to do instead, you will have to use the pipe. This can be a movie or null. And obviously, you cannot call duration on this. You'll have to match, basically, and deconstruct, not deconstruct, but get the right type of it to get the duration. And yeah, like you can combine it with the previous example where this can return a movie, null, or exception, basically. Extends any val. Does anyone knows what it does? Extending any val. This is very obscure. Many people ask me, what is this? Why did you extend any val? I thought any val was like primitive types. So I think it's confusing. And let's take an example. For example, we have this function, record view, which records a user saw this movie, right? And you will use it this way. And so a better way is using types, right? And it gives you good documentation. You have like, instead of using a string, you're actually using a movie ID or user ID, right? And you might have noticed this code there's a bug actually. It compiles fine and everything, but we swapped user ID and movie ID. This is a mistake that we've done. And this will work perfectly fine at compilation, even at runtime, actually. And you will have to debug it and so on. And so it's very strange that we didn't catch it at compile time, whereas we could have. And so instead, what people do is they wrap it in a case class to use an actual type, and then we can see that it fails at compile time. But this risks if creating an object for that. The JVM is pretty good at inlining those stuff, but there is a risk that it creates actually overhead, and then you have to, at runtime. And so what people do is they extend anyval, and anyval basically removes. It will inline everything, and the case class won't be there at runtime. So in ScalaMatsuri, we can use this opaque types, and basically the underlying type will be a string, and it will be known only in the scope where it's declared. But then we'll only know that it's a movie ID type. So in the companion object, I created an apply function just to lift a string into a movie ID, and then we can use it this way, right? And it's all type checks and everything. So just a little bonus, you might wonder why would you use opaque type instead of extending anyval? Well, you can do more complicated things like this. You can say a string non-empty. Basically, a movie ID is a string non-empty. So it gives you much more power on extensivity and so on. Right. So implicit classes. I have a friend. I'm laughing because I have a friend who is learning Scala, and he told me like, "What is this?" So basically, if you want, like, the main purpose of using implicit classes is to add functions on top of types. So for example, we are extending long. This is actually into the standard library right now. And so we are adding a function seconds to long. And if we have a function wait, we can call it wait 5 seconds, right? And so in ScalaMatsuri, this is much simpler and much more understandable, I guess. We can use extension functions and just implementing it this way. And then the usage is exactly the same. this is my favorite, the type class hack. So I think the Java way of doing is probably creating a thread encodable, and you basically extend it, on our movie type. We extend encodable, and we implement we implement encode here. And if you have a function that is sending data, basically it can send any encodable. Then you can encode and then send it somehow. And so it starts with 1. And then someone is like, we need to compare it. And then someone is like, I need to clone it. And then it goes like crazy until you get mad, right? So it would be cool if we had a separation between data manipulation and data structure. And this is what type classes are for. Also, another issue is that you cannot extend anything that you don't control from libraries, even like obviously I took a primitive type, but any library that you're depending on, you cannot add the encodable basically on it. So what people do is this way: they would create this thread again, encoder, and they would implement it here. I didn't do the implementation for movie, but for string, it's like let's say toString. And then the send function will be, I can send any data t if you give me an encoder of this t, right? If I know how to encode it, then I can encode it and send it, right? So I just wanted to note one thing is if you add, you add a client, a HTTP client, this maybe if you've been doing Scala for a long time, this is like normal to you, but the client is also an implicit. The implicit keyword doesn't just apply to the first one. And many people get confused with that whenever someone joins the team and he never did Scala, never did any Scala before. And so another issue that we have with this implicit is, for example, if this function returns a sequence of string, well, if we want to call the apply function of the string, so 0, it doesn't compile. Why? Because we are trying to call the implicit function here. So to fix that, we have to call explicitly apply. I think it's a bummer because we two features in Scala are just clashing each other. And so this is the way in Scala tree you would do. You just create delegates. You don't have to give a name. And then this is the way you would give, you would pass, you would require this implicit. And so as you can see, I used extension functions here. And we can just having the given here brings all the implicit, the extension function in scope inside the function. So you can call directly to JSON on the data on any t. This is really cool, I think, and much less boilerplate. And so this is an example with multiple parameters. You just add brackets, and the given is outside. So I was mentioning this implicit keyword that applies to all the parameters. This is much clearer here. Oops, sorry. And so you can also name them so that you can call them directly. Right. So untyped equality. This is so annoying every time we are doing refactorings. So let's say we started with creating this case class, movie, title, and duration, right? We create one, Black Mirror. I don't know if you saw this one. It's pretty good. And let's say we have also a function somewhere else in the code base, really far away, which gives you true or false if the movie is 500 milliseconds, right? 5 seconds. And then people are every time they come to me and they're like, duration, is it milliseconds or seconds? So what you can do instead, you can use, whoops, sorry. You can change that to duration. And this is much clearer. You create 5 seconds and so on, right? And then this is all compiling fine. And at runtime, it blows, it never matches. It's always false here, and no one will ever tell you. I think there is still a warning, but this is compiling all fine. And so in Scala tree, if you enable strict equality, then this won't compile, and this is pretty good. Then you'll have to refactor it to 5 seconds, right? Thread parameters. So I don't know if you guys are using cats effect or like any cats or Scala Z or whatever. Whenever we create a service, we want to create a service and we want to be independent from the effect. We don't want to specify if we are using IO monad or whatever. And so we use this type class, concurrent effect, or another. And this doesn't compile in Scala 2 because you can't have parameters in threads. And this is actually an implicit parameter here, this context bound thing. And so in Scala 3, we will have thread parameters. And at the beginning, I was wondering, why would I pass any parameter to a thread? Well, this is a good example, using implicit with it. And so, I should not say implicit, but more delegates and given. And so, yeah, this way. And then you can also remove the name, and you can come back to the context-bound implicits, right? So this is pretty good. I will use it. So tuple deconstruction in functions. Every time you have a list or an option of something that contains basically a tuple, well, you have to use this notation where you actually deconstructing the object. And at the beginning, I think beginners are just like copying the code and just put case here, it works, and whatever. We don't understand why, but yeah. And but this is just so annoying because every time you have to come back, and it's more like an ergonomic thing, I guess. But in Scala 3, it will just be deconstruct the tuples for you. You don't have to case match on it. And yeah, just like you don't have to use curly braces. Yes, it's a minor one, this one. Right, last one. So you might wonder, how are we going to migrate this whole thing from Scala 2 to Scala 3? Well, it's already painful. Scala 2.13 is out now, and it's been it's already a mess right now. I've been trying to upgrade some libraries, but it was it's just so annoying that we have to do this every time. And so this is the situation, right? You start, you're on Scala 2.12. You depend on a library, so on your project. You depend on a library on 2.12, and then you want to upgrade on 2.13, and boom, you can't. You can't depend on the 2.12 libraries because this is binary incompatible. And by the way, Java doesn't have this issue because they control the JVM, so they can do the necessary modification on the JVM. We can't because we don't have hands on it. And so you need your libraries to upgrade to 2.13, right? But when they do so, then all the projects that were on 2.12 and they want to stay on 2.12, they cannot depend on this new version. So it's not forward compatible also. So what people do instead, they cross-compile. So each library, like the library maintainers, they have to compile it multiple times for each of the target versions that they want. And so will this be the case when Scala 3 will be out? And all what I said, if you cross-compile to 3.0, basically all the features I told you, we won't be able to use it in the libraries at all. So this is quite annoying. And so what they did is they have this tasty representation. So it will be compiled to this tasty format, which stands for typed abstract syntax tree, and Y. And it will be included in every jars, and the compiler will be able to finish the compilation from tasty to the target bytecode, basically. And so this will be included in 2.14, and so that means if you upgrade to 3, you will be able to depend on any library that is on 2.14. And actually, it will work both ways. So if you're a library maintainer and you want to upgrade to 3, you will still be able to, users in 2.14 will be able to depend on your library. All right, that's all. Arigato. So I encourage you to go and see on .epfl. I'm not maintaining this thing. I've been playing around. You can go on Scasti. It's like it's really cool. Like I've been trying all my examples on it, and whenever I had an issue, I went on the Gitter. Just go on there, ask. Like you have Martin directly ask, like telling you, oh, yeah, it's a bug. Okay, and yeah, obviously we are hiring. So yeah, thank you.
Yeah, episode 9, thanks.
Oh, sorry. Yeah, this one?
Yeah, so if you remove the case, right?
Yes.
So with the case, it would be a partial function, right? So when you remove it, would it still be a partial function?
No, it's going to be actually a function too. If you do this in Scala 2.
So now it will be a proper function.
So now, I'm not sure about the internals, but if it's a case class, it's gonna just it's deconstruct it for you.
Okay, thank you.